Hello students, you are welcome to Success Care tutorial. This evening we are going to be looking at a very important topic in chemistry, balancing of chemical equation. Most times students find it difficult to write a balanced chemical equation, and most times they fail to distinguish between a balanced equation and an unbalanced chemical equation. Now, first and foremost, what is chemical equation? Now, chemical equation simply means the representation of chemical reaction in terms of the symbols of elements, terms of the symbols of elements and formula of compound involved. Chemical equation is the representation of what? Chemical reactions in terms of the symbol of the elements and formula of compound involved. Now, for you to write a balanced chemical equation, first of all, you must know the words, the symbol of each element, and you also know the formula of what? Compound. That is how to write compounds. You should be able to know how to write compound and also how to write the chemical symbols of each element. With that, you will be able to write a equation for a particular chemical reaction. Now, of course, we know that a chemical reaction takes place as a result of chemical change. Now, when you are trying to analyze what, you are trying to analyze a reaction that took place or you carried out to someone else, the person who you are narrating it to was not around, was not there with you. But with the equation, the person will be able to understand what you have done. So like I said, the chemical equation is a what? Representation of chemical reaction in terms of what? Elements, in terms of the symbols of elements and the formula of compound involved, as we have seen in this definition. Okay, let me highlight it. So that being said, then you say in a chemical reaction, in a chemical equation, the reactants are always written on the left-hand side and on the right-hand side. Now, in a chemical equation, you must what? There are two words, species. The first one is the word the reactants, which is known as the reactant species, which is written on the left-hand side, and the other one is the word product, which is written on the right-hand side. Now, this A, we are using this A plus B to represent any element. A plus B representing any element. A can be any element, in fact. Okay, let me open up a new page. A can be any element. A can be what? Any element. A can be, let me say, A can be hydrogen. A can be oxygen. A can be sodium. So in that order, A can be anything. A can also be a what? A compound. Let's assume A is equal to, let's say, H2O is a compound. So A can stand for anything. So A plus B reacting together to give you what? C plus D. Now take note that the C plus D are the products formed from this reaction. Now, here now the A plus B are called what? The reactants. And this one is called the products. Now an arrow is used to separate it. Now looking at this arrow, seeing this arrow is pointing towards the product side. Now in some cases you have this is standard way of representing what? A reaction. But you can see when a chemical equation is having double arrow, one points to the product and the other one points to the other side. Let me check. For instance, you have something like this. For instance, you have, okay, let me use this, something like this. Now, this type of arrow here, this time, let me increase this a little. Let me increase it. Now, this type of arrow we are seeing here is pointing towards both sides. Now, this arrow has a hook here, so let's assume that this is an arrow now. This one is pointing towards the product, this one is pointing towards the reactants. So this is called what? A reversible reaction. But here, this one only points towards the product, which is what? The normal way of representing an equation. Now, it's a balancing of chemical. Now, all equations are of no what? Value if they are not what? Balanced. An equation is of no value if it is not balanced. Now, equation must be balanced in order of the law of conservation of mass, which states that atom can neither be created nor destroyed, or changes from one form to another during chemical reaction. So an atom cannot be created. You cannot create an atom, cannot destroy an atom. That is the law of what? Conservation of mass. Say all equations must be balanced in order to comply with the what? Law of conservation of mass. Okay, let me put it. Which states that atom can neither be created nor destroyed. Atom can neither be created nor what? Destroyed. So what this thing simply means is that in an equation, whatever you have on the left-hand side must always what? Correspond with whatever you have on the right-hand side. Equations are though balanced through the use of coefficients in front of the formula and not by changing the subscript numbers within the formula of the products. So when you are balancing an equation, you don't need to change the formulas. You don't need to rewrite the subscripts. Assuming the equation is already given to you. Now, let's just take, for instance, you have this equation. So write a balanced chemical equation for the combustion of ammonia gas in air. This is the symbol, the formula for the reaction. Okay. This is the formula for the reaction. Here now, if you are balancing any, you don't need to rewrite anything. You don't need to change it. Now, all you need to do is to look at the elements involved here. Now, look at the number of what? Atoms. Now, if you look at this ammonia is NH3, and oxygen is the air, which is what? O2. So we have an oxygen molecule, and this one will form a mole of nitrogen 4 oxide and H2O. Now, how do you balance this equation? That's the question. How do you balance the equation? Now, step one here, we have step one, choose the appropriate coefficient or mole to balance the number of atoms and, okay, number of atoms of what? Atoms of hydrogen on both sides. Now, to do this, we place 4 in front of ammonia and 6 in front of water. And this has been done here. So for us to balance this, because we are having 3 atoms of hydrogen in ammonia, and we are having 2 atoms of hydrogen in water. Remember, the law of conservation of mass says that atom can neither be created nor destroyed. You don't destroy what? An atom. So what it simply means is that the mass of reactants is equal to mass of products. Is equal to mass of products. So whatever you have here in terms of the number of atoms, all of them must correspond together. If you're having 3 atoms here, on the right hand side, you must have what? 3 atoms. So we have balance for oxygen, hydrogen. So you see here now that here, we have place 4 here. Now this 4 that is outside there, this 4 that is here, multiplies the entire elements. And since it multiplies the entire element, so when we say 4 times 3 of hydrogen atoms, we are going to be having 12. We're going to be having 12. And 6 atoms of hydrogen, 6 times 2 here is what? 12. So we see that on both sides, hydrogen is now balanced. Now coming to step 2, put 4 in front of nitrogen, 4 outside, to balance the number of atoms of hydrogen on both sides. Now, like I said before, we have our 4 here. This 4 multiplies the whole elements. And here now, what it means is that we are now having 4 atoms of nitrogen. And here we are having 1 atom of nitrogen. Here in this place, we are having 1 atom of. So you see that we have increased an atom here, and this place the atom is being destroyed. So to balance it, we have to place 4 atoms. And when we do that, we have balanced the atom of hydrogen. And let's go over to step 3. Step 3 says balance the atom of oxygen on the left-hand side by placing 5 in front of oxygen. Let me put oxygen here. In front of oxygen, so as to have equal number of atoms of oxygen on both sides. On both sides. Now, since we know that we placed this 4 here, and we have 4 here to balance your nitrogen. Invariably, we have also increased the atom of oxygen. You look at this place. We have increased the atom of oxygen on the right hand side. Now, we are having 6 atoms of oxygen here, and we are having 4 atoms of oxygen. So if we add both of them together, we are having total 10 atoms of oxygen. So when you now look at this place, we are having only 2 atoms. So to do that, that is why we place these 5. So that we are now going to have an equal number of an equal number of oxygen. So when we do that, 4 plus 6 is 10. 5 times 2 is 10. And that will give us a total number of 10 atoms of oxygen. So here now, we are now having a balanced equation. Now for us to check if the equation is actually balanced, for us to check if the equation is balanced, for us to check if the equation is balanced. So what we are going to do now is, first of all, we are now going to look at the relative atomic mass of these elements. RAM stands for relative atomic mass. Of course, you know that each element have its own relative atomic mass. So here now we are going to be having hydrogen is equal to 1. Hydrogen is equal to 1. Nitrogen is equal to 14. And oxygen is equal to 16 as the relative atomic mass. So first of all, we are going to now calculate on the left-hand side. On the left-hand side here, we are having nitrogen and we are having hydrogen. 3 atoms of hydrogen, and we are having what? 1 atom of nitrogen. And because we have this 4, we have increased the number of atoms. So for us to do, let us now calculate if actually it is what? Balance. For us to calculate to know if actually it is balanced. So we are going to be having 4 times 14. 4 times 14 of nitrogen is what? 56. So here nitrogen is equal to what? 14 times 4 plus, we have 12 atoms of hydrogen because of this 4. 4 times 3 is 12. And for us to do that, that is 12 atoms of what? Hydrogen. And we said that hydrogen is what? 1. That is 12 times 1 plus. Now for oxygen, we have 5 times 2, which is what? 10. That is, we have 10 atoms of what? Oxygen. That is 10 times 16. Remember, you have 16 here. We have 16 here. So for us to do that, let us now check. 14 times 14 times 4 is what? 56. So we have what? 56 plus 12 plus 160. So this will give us, let's check, 15 plus 160 plus 12. So this should give us 2, no, let me get it right. 14 times 4 times 14. This is 56 plus 12 plus 160. So this will be our 228. So here on the left hand side, we are having 228 on the left hand side. Now let us check for this side if we are going to have the same thing. So since we have here for nitrogen, let me copy this arrow and paste it here. So nitrogen is what? That is 56 plus oxygen is 16 times 4 is 64. 64. That is, this will give us So this will give us, here we are going to be having 0, 5 plus 6 is 11, 12, 120. Sorry. So we're going to be having 120 plus. So we have 12, that is, this hydrogen is what? 12. So we have 12 plus, now 6 times 16 should give us 96. 6 times 16, 6 times 1, 6. It give us 96. So we are having here 96 plus 12 plus 120. So you see that here is 96. So cannot see that on both sides we are having what? 2, which is equal to what? 2, 2, 8. So on both sides now we are having what? 2, 2, 8 for the what? For the products. For the products. Let me use this. And this one is for the reactants. Good. So we are having what? Equal number of what? Atoms on both sides, and the equation is what? Balanced. Okay. Now let us now go to example 2. Let's go over to example 2. So write a balanced chemical equation for the combustion of ethane in oxygen. Now, the general formula for combustion of ethane is C8 plus what? It was CX H2X. CXH underneath, H2X H2S plus. Okay, we have here S plus what? Y over 4 plus oxygen. Now this one is what? For oxygen, and for this X is for carbon. This one is for hydrogen, and this is what? Oxygen. So here now we are having what? Here we are having Y over 2 HO. This equation, this thing is not correct. Okay, now let's quickly go over to balance of importance of chemical equation. It gives us information on the product that can be formed from the combustion of 2 or more reactants in a particular reaction. So a chemical equation gives us what? Information of what to be formed, the product that is going to work formed from a particular reaction. So at this point, I'm going to stop. And if you have any question, you can what? Send it on the chat box. Thank you for now.